This is the brief on cognitive dynamics, active inference, and self-organization. So today we're looking at this really fascinating paper by Friston, Sengupta, and Aletta. What they do is connect how basically everything, from simple life forms right up to our own brains, makes sense of the world. It's all about how living things are constantly, predicting what's going to happen next, and then acting to make those predictions real. It's about minimizing surprise. Here's what you really need to grasp. Okay, first up, the author suggests that any system that kind of sticks around and keeps itself going, think a single cell or, well, us naturally, tries to minimize something called free energy. Now think of free energy basically as how surprised the system is by what's happening around it. Less surprise, more stability. And this drive leads to what's called active inference. See, systems aren't just passive, they're actively predicting and then acting to make sure their predictions line up with reality. It's how it stays stable and kind of in control. And finally, this whole core idea of minimizing surprise, well, that's pretty much how our brains work too. It's basically the same thing as predictive coding, where our brain is constantly making predictions. When reality doesn't match the prediction, you get a prediction error, and that drives brain activity. Think about writing your name. Your brain predicts the feeling of the movement, and it fixes tiny little sensing mistakes on the fly to make it smooth.
So yeah, this work paints active inference, this drive to minimize surprise, as a fundamental rule explaining how all sorts of dynamic systems, from the simplest life to our complex brains, organize themselves, perceive things, and act.